Hello all, welcome to my YouTube channel. So in today video we are going to discuss about network concepts in Azure Kubernetes services. So if you can see with the help of this diagram, we basically have two model or two plugin in AKS. First is called a Kubenet, which is the default one, and another we have a Azure CNI. So let's understand in more details. So first, before going to explain the models of plugins which we have in AKS like Azure CNI or Kubernetes, first we understand few terms which is going to use more frequently whenever you are going to create a AKS cluster. So the first term here we have a node pools CIDR. So what does it mean node here? So node is nothing, it's a virtual machine where your application or your pod is going to run. And pools, so whenever you create a AKS cluster, it create a pool of virtual machine, like it create a basically a virtual machine scale sets where your virtual, suppose for your virtual machine scale set you have a two virtual machines, so those two virtual machines is called a pool of node. And another terms we here we have a CIDR notation. So CIDR is called a classless interdomain routing. So is an IP address allocation method that improve data routing efficiency on the internet. So in simple word, we understand CIDR as a, it's a basically with the help of CIDR we can easily identify how many IP addresses we are going to have in our network or in our cluster. So suppose for example we have a series called 192.168.0.0/24. So the slash 24 is called a CIDR notation. So with this help of this CIDR notation, we can easily identify, okay, these are many number of these are number of IP addresses which we are going to reserve for our AKS cluster. So the network where your node resides with Azure CNI. So again, this particular term node pool CIDR is applicable for both if you are using Azure CNI as a plugin or model, or if you are using as a Kubernetes as a model or plugin. And for both the both type of model, it is applicable. So if you are using Azure CNI as a networking model in your AKS, then the nodes is a virtual machine. Nodes get IP addresses from the subnet of the predefined VNet. So suppose, so first let's understand in more depth this particular line. So suppose whenever you are going to create a AKS cluster, you will have two options. The first one will be default, which is called Kubenet, and another one will be CNI. So and another option we will see here, we will see in coming videos, there is an option called bring your own virtual network. So if you are using Azure CNI as a plugin, and you can still you have an option, you can bring your own virtual network. That's where I have defined a predefined VNet. Don't get confused with the term here, predefined VNet. It is not required. If you are not using predefined VNet as well with Azure CNI, then Microsoft Azure AKS cluster is automatically create a virtual network for you, and from that virtual network, whatever the subnet it will create for you, from that subnet you will get the IP address of the virtual machine and node as well, the same IP addresses we will see in coming video or in coming slides. What with Kubenet, nodes get IP addresses from the subnet of the VNet that resides in the system resources. So in the Kubenet case, the whatever the nodes we have, the virtual machine will get the IP addresses it which is created by the Microsoft itself. So you here you again we have an option here, you can define your own virtual network as well. But one node get the IP addresses whatever the subnet will be created by the Microsoft. So I will say don't get too much confused on this particular line here. We will see very finest way in coming slides with the help of diagram, so you will get more clarity on this. So just for time being, just understand with Azure CNI you will get the node will get the IP address from the subnet, and which is created by you or either Microsoft. And with the in Kubernetes also, nodes get an IP address from the from the virtual network which is created by the Microsoft as well. We will see this node pool CIDR in coming slides in more accurate way. so it will be easy to understand. Next term here we have pod CIDR. So pod CIDR is the pool of addresses where the pods get their IPs from and is usually different from the node address pool. So again here this term will be used for both the networking model Kubenet and uh, Azure CNI. So in case of Kubenet, pod receive an IP address from the logically different address space. This particular address space it is completely separate from your virtual network. The subnet will not be part of your virtual network. Whatever the IP addresses your pod will receive, that IP address is completely different from your virtual network. Pods can't communicate directly with each other. User defined routing or IP forwarding is used for connectivity between pod across the nodes. So let's understand with the help of this particular example. So suppose we have this virtual network called 192.168.0.0/60, sorry 16, and under this virtual network we have a subnet called node subnet, and if you see the node subnet IP here address is 192.168.1.0/24. Now this is the node 1 and this is the node 2. If you see the IP address of node 1, we have 192.168.1.4. So this IP addresses is coming from the node subnet, but here we have the pods, 1 2 3 pods we have. But if you see the pod IP address is completely different, it's not a part of Azure virtual network here. So this pod IP is 10.244.0.2, and again here we have different 0.3 0.4, and on this particular node 2 we have again different series 10.244.1.2. So whatever the IP addresses this particular pods is getting, it's basically completely different. Microsoft creates your like basically it's created by Microsoft itself, but these pods can't communicate with each other. To communicate these pods you have to define the routing or network address translation, something you have to routing tables and all you have to define here to communicate these pods. So this is the case in the case of Kubenet. Now with Azure CNI, each pod receives an IP addresses in the IP subnet and can directly communicate with other pods and services. So if you can see here, this is the Azure virtual network. Whatever the IP addresses this particular virtual machine is get, the same IP addresses, like whatever the range you have defined in the Azure virtual network and subnet, the same IP addresses pod as well receive, and node is also received. Node 1 is also received, and there is no NAT or UDR user default user. So I forget the term. What was UDR? It's called user defined routing. You don't need to specify any UDR and IP forwarding to communicate this particular pod with each other. It can directly communicate in the case of Azure CNI. I hope it's clear. We will see in Azure portal, then it will be more clear. Next term we have a Kubernetes Services Address Range or Service CIDR. So we have one is Node Pool CIDR, another one we have Pod CIDR, and the third one we have Services CIDR. So these are the different services or terms which Microsoft AKS cluster provide. So the service CIDR is used to assign internal services in the AKS cluster to an IP addresses. So like if you are creating ingress controller, like this is a completely different uh, IP addresses will be allocated, and this IP addresses will not overlap with any of your network. See, this range should not be used by any network element on or connected to this virtual network. So this particular IP address is completely different from your node IP range or pod IP range. It should be completely different. However, we can reuse the same service CIDR for multiple AKS cluster. Sorry. Suppose we have two AKS cluster, but we can use same service CIDR. Service, for example, we have 10.0.0 1 slash something. So the same IP range, if you want to use service CIDR use for another cluster as well, then you can use that. We can use any private address range that satisfy the following requirements. So these are the requirement, if which is applicable if you whenever you are configuring service CIDR. So the first one we have, must not be within the virtual network IP address range of your cluster. So whatever the IP at range or CIDR you will define for your services, that should not match with your virtual network address range. Another one, must not overlap with any other virtual network with which the cluster virtual network peer. Suppose if you have a virtual network peering enabled, then the service CIDR is also should not match that particular peered virtual network as well. Like if you have virtual VNet 1 and VNet 2, and VNet 1 and VNet 2 is paired with each other, and whatever the range IP range you have defined for VNet 1 and VNet 2, that should not match with the service CIDR, otherwise it will not work. And must not overlap with any on-premise IPs. So if you are connecting AKS with your on-premise environment or on-premise network, then also the service CIDR should not overlap with your on-premise network as well. Must not be within the range. So this particular range cannot be used when you configure the service CIDR. So these are the range like 169.254.0.0/16. So these are the basically range which you cannot use when you are configuring the service CIDR. Now we will see more details of both the plugins like Kubenet and Azure CNI. So the Kubenet networking option is the default configuration for AKS cluster creation with Kubernetes. Nodes receive an IP address from the Azure Virtual Network subnet that we already discussed, and pods receive an IP address from the logically different address space than the nodes Azure Virtual Network subnet. If I'll go back to my previous slides, so if you see here, this pod is getting different IP addresses and node is getting different IP addresses, but this node IP address is coming from the Azure Virtual Network subnet. A network address translation is then configured so that the pod can reach resources on the Azure Virtual Network. So some kind of user defined routing and NAT you have to enable so your pods can communicate with each other. The source IP address of the traffic is translated to the node primary address. So whatever the traffic is coming to your pod, it basically translated to your node primary IP addresses. So whenever, like, so for example, if you have deployed your application with the help of Kubenet networking model, then whatever the IP addresses will be your virtual node, that IP address should be accessible from the outside of the world, not the pod IP addresses. You can let the Azure platform create and configure the virtual networks for you, or choose to deploy your AKS cluster into an existing virtual network subnet. Only the nodes receive a routable IP addresses. The pod use NAT to communicate with other resources outside the AKS cluster. So if you can see here in this particular diagram, this is with the help of Kubenet. If you see the virtual network VNet, we have something called 10.0.0.0/16, and the subnet IP address we have here 10.0.0.0/24. What if you see the node particular, this node is getting the IP addresses from the subnet, but the pod IP address, if you see 10.244.0.101, this is different IP address range for this pod 1, pod 2, and if you are see another node, here we have a different series 2.201. So the pod will receive a logically different IP addresses in the case of Kubenet networking model. Next we have Azure Container Networking CNI networking. So this is the another networking model which we have. So the AKS cluster is connected to the existing virtual network resources and configuration. So you can define a predefined virtual network. If you are not using predefined virtual network, then also node and pod will get the same IP addresses. With Azure Container Network Interface, every pod get an IP address from the subnet and can be accessed directly. So whatever the subnet range you will define, that's from the pod will get the IP address from that subnet range itself. So it can directly communicate with other services. Systems in the same virtual network as the AKS cluster see the pod IPs as the source address for any traffic from the pod. So in Kubenet, the source traffic was from the node IP. What in the case of Azure CNI networking model, the source traffic can be directly from the pod IP as well. System outside the AKS cluster virtual network see the node IP as the source address for any traffic from the pod. So if you are accessing something from the outside of the virtual network, AKS virtual network, then the node IP address will be the source address for any of the traffic which is coming to the pod. A drawback with traditional CNI is the exhaustion of pod IPs address as the AKS cluster grow, resulting is in the need of rebuild the entire cluster in a bigger subnet. So if you are using this, see, for every networking model we have some advantages and some disadvantages as well. So in the case of CNI, we will see in coming video what all the benefits, what all the advantages or disadvantages we have in all the networking models. If you are using Azure CNI, you will see your IP addresses will like you have to plan your IP addresses before building the AKS cluster because it will use a lot of IP addresses. There is a dynamic IP allocation capabilities in Azure CNI which solve this problem by allocating pod IPs from the subnet separate from the subnet hosting in the AKS cluster. There is a way, another way in Azure CNI where your pod will get us different IP addresses. Like you can create a, for example, you can create a two subnet. The one subnet will be like node subnet and pod subnet. So the node, the virtual machine where your pod is running, that will get the IP address from the node subnet, and the pod subnet, whatever the pod we have on that particular pool, it will node, it will get the different IP addresses like whatever the range you specify in the pod subnet option. For intercommunication with other Azure services, example virtual machine, the source addresses of the packet arrived from AKS backend by Azure CNI is the pod IP addresses. So it adds transparency to the network. So there is no need to define any kind of user defined routing or net to communicate because the pod can directly access to the other services as well. Each node is configured with a primary IP address. By default, 30 additional IP addresses are pre-configured by Azure CNI that are assigned to pods scheduled on the node. So whenever you create a AKS, so like if you have two nodes, node 1 and node 2, so node 1 will reserve 30 IP addresses, node 2 will also reserve 30 IP addresses. So you have to plan more wisely whenever you are using Azure CNI, otherwise you have to rebuild the entire AKS cluster again. So if you see here, we have the VNet range in Azure CNI, we have VNet 10.0.0.0/16 and the subnet here we have 10.0.0.0/24. Now you will see the node will get the IP addresses from this range 10.0.0.0.1 something, and the pod is also getting the same IP addresses from the subnet range itself. So you see 10.0.0.1.1. So from this range itself, this pod is also getting IP addresses. Another we have networking model. You will not see this option, but with the help of command line, you can also use networking mode as a Azure CNI overlay. So this is something similar to the kubenet model, but it is not similar. Like it is not the same as a kubenet, but it's something similar with the kubenet model. Let's see. With Azure CNI overlay, the cluster nodes are deployed into an Azure Virtual Network subnet, whereas pods are assigned IP addresses from a private CIDR logically different from the VNet hosting the nodes. So in Kubenet, what was happening? Nodes are getting IP addresses from the pod, or sorry, from the virtual network, but the pods are getting the IP addresses separate differently from the subnet. And the same thing is happening with Azure CNI as well. The nodes and the cluster where you are host in virtual network, those will get the IP addresses from the subnet, but the pods IPs will be completely different. Like logically different, so it will be created by, like it will be private IP addresses which AKS will allocate to your pods. In overlay networking, only the Kubernetes cluster nodes are assigned IPs from the subnet. As we discussed, what the cluster node will get the IP address only from the subnet. A separate routing domain is created in the Azure networking stack for the pod's private CIDR space, which create an overlay network for direct communication between pods. But what was happening in Kubernetes, we were not able to directly communicate between the pod. But in the Azure CNI, it will automatically create a kind of routing table for you, so you can directly communicate between the pods. So this is the main difference between a Kubernetes model and Azure CNI overlay. Communication with endpoints outside the cluster, such as on-premise and peered VNet, happened using the node IP through network address translation. Azure CNI translates the source IP of the traffic to the primary address of the VM, which enables the Azure networking stack to route the traffic to the destination. So basically, what is happening here, what this particular line is trying to say, whatever the pod IP, that pod IP will communicate to node IP, and node IP will interact with the whatever the destination IP or destination like end user, that will be redirect to that particular IP addresses. Like suppose for example, if I'm accessing some websites, so this is coming from different mechanism. Like first it will go to load balancer, then from load balancer it go to node, then from node it will get to the pod. So those mechanisms will be used in Azure CNI. Endpoints outside the cluster can't connect to the pod directly. You will have to publish the pod's application as a Kubernetes load balancer service to make it reachable on the VNet. This solution saves a significant amount of VNet IP addresses and enable you to seamlessly scale your cluster to very large size. So when you are like, you suppose you have 100 nodes, then only 100 IP addresses will be allocated to your node from the virtual network, and the pod will get a different IP addresses. So in that case, you will save a lot of IP addresses in your virtual network. So if you see here, node 1 IP address we have 192. Okay, let's understand from here. So this is particular virtual network. The range is 192.168.0.0/16, and this is the subnet 1.0/24. So the node 1 will getting the IP address 192.168.1.4. Here we are node 2 is getting IP address from the 1.5, like it getting the IP address from the virtual network itself. But the pod CIDR, if you see, this is completely different. So that will be the range of /24. So 10.10.1.0/24. The pod CIDR here again will be different, 10.1.0, sorry, 10.2.0/24. So but these pods can communicate directly with each other because this overlay networking will be enabled when you configure Azure CNI overlay. So I hope it's clear. Now we will see benefits and limitations of Kubenet. Then we will see for Azure CNI and Azure CNI overlay. So reduced number of IP addresses that are reserved in the network space for pods. So because in the Kubernetes, pod will not get IP address from the virtual network, so it will reduce the number of IP addresses. It is simpler in design management than Azure CNI. An additional hope is required in design of Kubernetes, which adds minor latency to the pod communication, because you will define some kind of user defined routing, IP forwarding, then it will basically, you will see some kind of delay in your communication to the pod. Route tables and user defined routes are required for using Kubernetes, which adds complexity to operation. Azure network policies are not supported. If you are using Kubernetes, then you cannot use Azure network policies. You should use Kubernetes when you have limited IP address space, and most of the pod communication is within the cluster. Like that cluster should not, the pod should not communicate with outside of the services. Then in that case you can use Kubernetes plugin. You don't need any advanced AKS feature such as virtual node or Azure network policies. In that case you can use Kubernetes. Like, it is not recommended to use Kubernetes in your production environment, but for those, if you have simple application, single application, in that case you can still use Kubernetes. Benefits and limitations of Azure CNI. It allows for the separation of control and management of resources. Definitely, because it is easy to allow like security rules, network policies. Pods get full virtual network connectivity and can be directly reached by their private IP address from the connected network, because the IP addresses node and pod will get the same IP addresses because from the node subnet. So it is directly, we can contact to the pod. Require more IP addresses, because from the same range pod is also getting IP addresses and node is also getting IP addresses. So you will require more IP addresses if you are using Azure CNI. Traffic coming from pod doesn't go through net. Pod that stabilize communication to other resources can be identified. Virtual nodes are available only with Azure CNI, and Windows node are available only with Azure CNI. If your application wants to run on Windows platform or Windows pod, then you should use Azure CNI, because Kubernetes doesn't support Windows node. Use Azure CNI when you have available IP address space. Resources outside the cluster need to reach pod directly, like some kind of database for backend. Most of the pod communication is to resources outside of the cluster. You don't want to manage user defined routes for pod connectivity. In that case, you can use Azure CNI. Benefits and limitations of Azure CNI overlay. So this solution saves a significant amount of VNet IP addresses and enable you to seamlessly scale your cluster to very large size. An address and sorry, an added advantage is that the pod private CIDR can be reused in the different AKS cluster, truly extending the IP space available for containerized application in AKS. Because every pod will have separate CIDR, sorry, every node will have separate pod CIDR block, so you can use same pod CIDR block for another cluster as well. It supports Azure network policies. Does it don't support AKS advanced features such as virtual node. Overlay can be enabled only for few new cluster. Existing already deployed cluster can't be configured to use overlay. If you have existing cluster, then you cannot use or configure Azure CNI overlay. Use overlay CNI when you would like to scale to a large number of pods but have limited IP address space in your VNet. Most of the pod communication is within the cluster. You don't need advanced AKS features such as virtual nodes and etc. So these are the limitations and benefits of Azure CNI overlay. Another few terms here: Kubernetes DNS service IP addresses. You will see when you see when we configure AKS clusters. So what it terms means, basically the IP addresses of for the cluster DNS service. This address must be within the Kubernetes service address range, and don't use the first IP address in your address range. The first address in your subnet range is used for the Kubernetes.default service cluster local address. So we will see this particular terms. DNS name prefix. So DNS name prefix is used with the hosted Kubernetes API server fully qualified domain name. You will use this to connect to the Kubernetes API when managing containers after creating a cluster. So you can have fully qualified domain name when you configure DNS name prefix. So that's all. Now move to Azure portal and we will see Azure CNI and Kubernetes plugin model. So I have already created a Kubernetes cluster. So if I'll go here, so if you see the first cluster I have called AKS-CNI. So this AKS cluster I have configured with the networking model called Azure CNI, and the another we have Kubenet AKS, which is the default one. So first see Kubenet DNS. So in Kubernetes DNS, nodes is getting the IP addresses from the Azure Virtual Network, but pod was getting IP address from the logically different address space. So that we will verify here. So if I'll go to workload, if I'll go to pods here, now you will see the pod IP address range start from 10.244. If I'll go to node pool, so now here you can see this IP address of node is 10.224 and pod IP was having, we were at 10.244 and here we have 10.224. So the node will have the IP address from the virtual network. Let me open the duplicate tab and we will see the virtual network for this particular uh, Kubernetes AKS. So if I'll go to virtual network, so this is a Kubenet one. If I'll open here and if I'll go to subnet, now you will see this particular Kubenet subnet will have 10.224 and the IP addresses of the node is 10.224. So the node is getting IP addresses from the virtual network, but the pod is getting IP addresses from the logically different address space range. Similarly, if I'll go to Azure AKS CNI, in Azure AKS CNI, pod and node will get the same IP addresses, like the IP address from the Azure Virtual Network itself. So let me go first AKS CNI. So here we have AKS subnet called 10.224.0.6/16. Now if I'll go to workload and if I'll go to pod here, so if you see the pod IP addresses, we have 10.224.0.200, so the same series, and the subnet series also we have 10.224.0.0. so the pod is getting the IP addresses from the Azure Virtual Network subnet, and the same we have to verify node as well. The node IP is also with the same series. So let's go to node. So if you see the node IP address 10.224.0.113, so the from same series, same subnet, we are getting the IP addresses for pod and node as well. But in Kubenet, the node IP addresses we are getting from the subnet, but pod IP is logically different. And next thing we will see the service. So if I'll go back to here, if you see the services and ingresses, the cluster IP 10.0.0. So this particular IP range should not match with any of your existing BNet or existing address space range. This should be completely different within your AKS cluster. because if you see in this particular subnet we don't have this particular service range. So whenever you create your AKS cluster, that time you have to define the service range. Let me try to create one more cluster. I just want to show you the service CIDR where you have to specify. So if I'll go to networking, here we have option you bring your own virtual network with the both option Kubenet as CNI as well. uh, so here you can define your address Kubernetes service address range and DNS service IP is, this IP address should not be the first IP of your range. If you see a 10.0.0.0, the first IP will be 10.00.1, but it is not, like it is not, it should not use the first IP. That's why it's automatically taken the dot 10. So I hope this networking models like Kubenet and Azure CNI is clear for you. In case if you require any more depth on this part, then you do let me comment. I will definitely make another video of your whatever the query you guys have. So that's all for today. See you next video. Thank you so much.